This is the industrial controls introduction video for safety. Uh, we're going to talk about some electric shock and electrocution. The first thing I ask my students is if any of them have been electrocuted. And sometimes some people will raise their hand, and I will have to say, no, none of you have been electrocuted. You'd be dead if you were. So the answer is some people have been shocked. And the question is, what does that mean? And how does that affect our body along the way? Here's a chart that talks about the effects of current in the human body. And the data was gathered by the National Institute for Occupational Safety and Health. And this table shows the small amount of current, potentially as low as 50 milliamps, that can cause death. You see that right here. Extreme pain, respiratory arrest, breathing stops, muscular contractions, death is possible. At that point, we have this issue of lock, where our muscles lock in, and what happens is the muscles contract, and if you're on a circuit, you're fully energized at that point. It goes all the way up to 1,000 milliamps to 4 amps, well, 1 amp to 4 amps. That means the heart pumping ceases at that point. Muscular contraction and nerve damage fully occur, and anything over really 4 amps is an issue. For reference, a household circuit minimum current rating is 15 amps. That's more than 300 times what's required for death to be possible. But here's the good news. Ohm's law comes into play. This current is what's required for the human heart to cause these reactions. The National Institute of Safety and Health states that under dry conditions, the human body can have a resistance as high as 100 kiloohms. So using the lowest level of potentially lethal current, and Ohm's law, we can calculate out V equals I times R. 500 kilovolts is what's required to push that amount of current through the human body. That's assuming from your hands through your heart and down. That 550 milliamps needs to go through the heart to cause the issues. However, the National Institute of Safety and Health also states that wet or broken skin can drop the resistance all the way down to 1 k ohm. Voltage does break down the skin's ability to resist over time, which can reduce the resistance down to 500 ohms. So let's recalculate that. That's as low as 25 volts in a bad situation to push 50 milliamps to make death possible. So the whole point of this set of slides is to show you that complacency is an issue. Do not be complacent. There is a potential to get seriously hurt in electrical equipment. Time and experience will aid in seeing the potential safety threats, but even with familiarity, risk remains. Don't get complacent. Also know that the intention of this is to inform and not cause fear, but rather instill a better respect for electricity and an understanding as a powerful tool. Electricity is a friend when precautions are taken. Thank you very much.